In this lesson, we'll go over controlling a flow toolpath for 5 axes. After completing this lesson, you'll be able to create a multi-axis flow toolpath for 5 axes and analyze a flow toolpath for part collision. Let's carry on with the file from our previous example, and now we want to take a look at using our multi-axis flow in a multi-axis operation. So we're going to get started by going to multi-axis flow. We're going to be using the same tool, but in our geometry selection, we want to take a look at an area on the side of our part. So for this purpose, I'm going to just simply select this face, which is obscured by this rib on our part. Notice the orientation of the UV curves. We're going to go into our passes section and we're going to increase this to 25 and allow it to cut in both directions. If I say OK to this operation, it's going to try to calculate it based on our 3 axis parameters. Now in this case, if we were to look at the direction the tool is coming from, it can't see the selection at all, which means it can't create that toolpath. But if we go back in and we edit the parameters in our passes section, if we use multi-axis, then we simply say OK. We'll allow it to regenerate this toolpath with the ability to tilt the tool in 5 axes. So now that it can tilt the tool, notice that it's creating the toolpath on the selected face. Let's go ahead and simulate this toolpath and take a look at what the cut looks like. Again, our stock is based on the solid body, so we're not going to see any stock removal. But what we do want to look at is the direction that the tool is moving back and forth, and making sure that it is actually changing its orientation based on the selected face. So as it moves back and forth, you can see that the tool is staying normal to the surface that we selected. If we modify those toolpath parameters, we can change the UV direction. We can say along V, which will recalculate it in a vertical orientation as we're looking at it. This time if we simulate it, we'll see that the tool is moving up and down rather than moving side to side. Depending on the selected geometry and potentially some of the surrounding geometry, you might have to decide whether or not to make a U or a V style direction cut. In some cases, it really won't have any effect. It will of course change the direction of the cut, but in some cases one way might not be better than the other. In our passes section with multi-axis turned on, we can also adjust some of the parameters that we've seen before, such as forward or sideways tilt. We can adjust the minimum and maximum tilt, as well as the fan distance, the segment length, as well as the axis sweep. In this case, I'm going to adjust the forward tilt to be 10 degrees. I'm going to change the isometric direction to along U, and I'm going to change the tangential fragment distance to be 0.05. We'll select OK, allow it to recalculate, and then we'll simulate this toolpath. So let's go ahead and play through this toolpath and take a look at the orientation of the tool. So notice now the tool has a slight angle where it's leaning toward the mounting plate for this part. We can also see that the tool is actually contacting the surface and removing a small amount of material. Let's go ahead and head back into those parameters. And let's change the forward tilt back to 0. And let's adjust the sideways tilt to 10 degrees. Keep in mind that forward and sideways are going to be relative to the U or V directions. Now let's go ahead and simulate this toolpath and see how that affected the tool angle. Now you can see that the tool is angled down a little bit more than it was before, but in terms of this orientation in the Z-axis as we're looking at it, it's keeping it normal to the selected surface. So again, these options can come in handy, whether or not you're trying to drive the direction the tool is dragging across the surface, or if you're trying to avoid some surrounding geometry. I'm going to reset my sideways tilt back to 0 degrees. I'm going to leave my minimum and maximum tilt values, and I'm going to turn on my smoothing. The smoothing tolerance will change the properties of the actual curves that the toolpath is following. By changing the smoothing tolerance, or even just turning that option on, you might get a better final result of your machined part. While we can't see the difference on the screen, we will see the difference when we finally machine our part. Let's go ahead and take a look at this in simulation one more time, and we can show the toolpath, and notice that we can show the points of the toolpath as well as the axes. We can also show all toolpaths, and if we zoom in, notice the number of points that we see on the screen, and you can see the points as the toolpath is turning and changing directions. If we go back into our parameters, and we go back into our smoothing tolerance value, and let's change this to a 0001, say OK, allow it to recalculate that, then go into simulation. You'll notice that when we show axes on the points, we can see the number of points displayed with the yellow rapid movements. Now these yellow lines aren't actually rapid movements where the tool is pulling up and away, but they're just an on-screen representation of where these points are in 3D space. If we go back into our toolpath, back into passes, we also have a tolerance value here. We can change the tolerance value, which every time we talk about tolerance or smoothing, it's going to be the fit of the curve to the actual geometry. When we talk about the fit of the curve, and we're dealing with parametric parts that have things like straight lines and fillets with constant radii, these are generally easier for us to visualize because we're dealing with either an arc or a straight line or even a complete arc, which is a circle. But when we're dealing with these curves that are laid over these complex boundaries, these tolerance values might make the difference between getting a very highly faceted 3D cut part to getting something that's nice and smooth. We also have to think more about the size of the tool and the surrounding curvature when we're machining parts like this. Obviously, if we have tight areas that we need to machine, it's going to be easier to use a smaller tool to get into those areas. But when we're dealing with the big broad areas, we might actually want to do a different operation where we're using a larger diameter tool because it doesn't require such a fine radii. Let's go ahead and duplicate our flow toolpath. And then we're going to right-click and edit and change our selection. This time I'm going to select this face here, and I'm going to say OK without changing any of our other parameters. This is a tricky one because it wraps around the part, and we're obstructed on one side by the mounting plate, and then on the left and right we have additional geometry that's going to cause problems for us. So let's try to have it calculate this geometry as a toolpath and see how it handles the collisions. Once it's calculated, let's take a look at the results. So you can see that we have a lot of rapid movements and some feed movements coming into the surface, and you'll also notice that we have a warning. The lead radius has been decreased to avoid linking gouging. Let's go ahead and simulate this and take a look at the results. I'm going to turn off the toolpath display and simply play through this to see where the tool moves to and how it's accessing this geometry. So you'll instantly note that it hits the mounting plate. It hits these arms here. And if we turn off the original model and we're just looking at stock, you can see exactly the number of collisions and gouges that we're having with the holder and the tool itself. So this is obviously not a great way to machine a part because we're taking more information, we're crashing into the part. So we really need to talk about ways in which we can handle collisions when we're talking about these multi-axis toolpaths. But before we make any more adjustments, let's go ahead and save the file before we move on to the next step.
Thank you for watching our channel. Please like, share and subscribe our channel, and don't forget to press on bell icon.